This is a quick video showing the VESC motion control launch code that I have written on the VESC here. I have a Castle motor with Hall sensors hooked up to the VESC, so I get very fine, slow speed rotor position feedback. In the VESC tool scripting tools, in the list BM scripting, which is the low-level code actually that VESC is written with, I am actually able to calculate the torque with a given motor phase current right here. I'm manually setting the current, but you can also get like a real-time current with this right here, get current. But right now, for example, if I set 10 amps, a motor phase current, which I can demonstrate right here with my real-time data. If I put a motor phase current limit on the motor, it will cap the phase current at 10 amps. And just to demonstrate the code here, I'll stream the code, and with 10 amps of current, we can use this equation right here, which is one of the field-oriented control equations in order to figure out shaft motor torque even in the rotating reference frame. So while the motor is spinning, this is the torque in Newton meters. Then we can get the linear force by dividing by the pulley radius. So VESC already has a parameter that is something called wheel diameter. You then multiply that by 0.5 to get the radius. I've just used this right here in order to manually set. So 21 millimeters is 0.021 meters. So divide by 0.021 meters in order to get the linear pulley force as if it was pulling up a string in newtons. I then have a couple launch parameters, which would be like a launch angle of the launch bar and the aircraft weight in grams. Then I get the gravity component of the launch angle. I can calculate, going from the force of the pulley in newtons, I can calculate that in grams. And so 9.85 newtons equates to about a little over a kilogram of force on this motor with this radius pulley at 10 motor phase amps. And so if I take the ratio of that force with the aircraft weight, I get the force ratio. And then in order to calculate the final motion of the launch, I subtract the G component. In other words, how many G's end up resolving onto the component depending on my launch angle from the force ratio. And from that, the final, what I would call launch motion, G. So at these parameters on this motor with this pulley and 1 kilogram of launch weight, it would launch the plane at 1 G with launch motion G here. If I go up to the top, and let's say I sent 20 amps and stream it, you can see I get about 2 Gs. Now if I go back to 10 amps and go back to about 1 G, but then let's say I half the weight of the aircraft, 500 grams, should also go back up to 2 Gs, because I'm applying a 1 kilogram force to a 500 gram object, which would double the acceleration, F equals ma. But then if I go back to 1 kilogram, meaning 1G, and then I change the launch angle to, let's say, 30 degrees, my G gets cut in half, because on a 30, 60, 90 triangle, that G component gets cut in half. And if I did something like, let's say 45 degrees, the G component, I believe it's around like 0.7. So it leaves about 0.3, yeah, 0.298, 0.3, it leaves about 0.3. So on a 45 degree angle, a 30 degree angle leaves about half, a 45 degree angle only leaves about 0.3 of the horizontal equivalent acceleration G. And let's say, to get around this, this motor has a maximum capability of 100 phase amps. This is going to be a little bit of a spicy launch here. I can overcome that with 9.3 final G's of acceleration of a 1 kilogram aircraft at a 45 degree launch angle. Now, 45 is probably a bit crazy, probably do more like 30, but let's say your launch weight went up to around 5 kilograms. You can still get about 1.5 G's of acceleration. If I wanted to find like around the 2G, I'm just gonna guess here, maybe 3,500 grams, a little over 2 G's, 2.3 G's, launch angle 30 at 3.5 kilogram launch weight with 100 motor phase amps. And it could probably even go higher, because it would only be experiencing that current load on this motor for what, maybe a few seconds. Now, in order to get the final speed of the aircraft with this acceleration, you would need to calculate the distance of the launch rail and the time under which it is experiencing that acceleration. That's obviously to go in the calculator, but this is just a simple motor current calculator setup, knowing a few FOC parameters of the motor.